let's look at the questions in your tutorial sheet on momentum. First, we are asked to describe how a helicopter can hover. Right, here we have a helicopter, and the helicopter hovers because of the strong downdraft of air. What is the downdraft of air we are talking about? So if we look at our helicopter, the air, stationary air, is drawn down through the helicopter blades. This drawing down action is created by the rotation of the helicopter blades. And according to the solution, we are told that it manifests as a momentum on the airstream. The initial air before the helicopter is relatively stationary. After the helicopter, there is an increase in momentum. So because of the difference in momentum, the helicopter creates a downward momentum. Very important, it creates a downward increase of momentum. As a result, there is a force on the air acting equal and opposite to counter this momentum. So this reaction force, according to Newton's third law, is the force mentioned here. The helicopter stays aloft by pushing the air with a net force equal to its weight. We now look at the next question. It regards the acceleration of a kite hit by a water jet. Let's have a picture of it. Now here we have a picture of the jet impacting the kite. We are to figure out, according to the solution, why the acceleration is not constant. Now the answer follows in these two paragraphs. The momentum force exerted by the water on the plate is the mass flow rate of water multiplied by the velocity of the jet. So now if we look at the formula, the force is equal to the mass flow rate times the velocity. This is the momentum effect, because as the water impinges on the kite, there is no velocity leaving in the x direction, and the velocity in, which is v, is now entirely converted into your momentum force. The mass flow rate m dot is the density of the water multiplied by the area of the jet impacting the kite, or the area of the jet leaving the nozzle. We are assuming that the jet moves without breaking up, multiplied by the velocity gives you the mass flow rate. We simplify it by looking at this formula, the density times the area times the square of the velocity. The next line is pretty important because it says that the velocity v is relative to the kite. So now we have to be careful. The velocity v is in. If you take a look at the velocities now, you will notice something quite interesting. The velocity of the jet is constant. However, small v, which I've indicated here, the velocity of the kite increases. Why? Because there is an acceleration from 0. Initially, the kite velocity is 0, but because of the water jet momentum, the velocity of the kite increases. Because of that, now the relative velocities, the relative velocity shown here as capital V minus small v, minus small v, capital V minus small v, begins to decrease, because remember, v is an increasing value and capital V is a constant value. So as a result, the momentum force on the kite decreases.